So in the previous class, we just tried to see how language, the role of language or role of symbolic logic, and how we could formulate quantum mechanical principle, or we can have a quantum mechanical logic. So role of language. So one comment which I wanted to share, which I just somehow missed, is that Reichenbach, according to him, there is a great advantage that we can discuss questions of logic outside the sphere of atmosphere of metaphysical conceptions. So that's it here. I disagree with it. That even when we assume that things are logic, so we can have a logical metaphysics. So the construction of metaphysics by which Reichenbach is heavily influenced or converted to as a belief is a logical empiricism. How empiricism and logicism as a two philosophical constructs or theoretical constructs, how can embed quantum mechanical principles or quantum mechanical logic. So if you incorporate or include metaphysics as a broad discipline, broad thing, which not only it's something, it's actually you say being qua being, existence via existence. It's the existence cannot be logical existence or empirical existence. You can have other existences. So that if you widen the domain of how we define metaphysics, so logical empirical way of looking at things, and how we just see language, the role of language, which itself a very broad idea, whether language can or words are sufficient to containers of the description, or there are fundamental intrinsic limitations or tautologies. If these if the happenings of the world, if we can express them in terms of tautologies or agreed upon linguistic rules, so limitations of language and limitations of logic, like Bourdieu's principle. So that discussion, this comment is off the cuff, but since we are trying to formalize quantum mechanics via a logic, so we have to also we can there are other perspectives also keeping this point. So you can have, for example, interpretation through a valued logic. Means one is logic, we say, for example, we have also a role of how we just modeled, once we have observed language, observed thing, and what we are interested as a part of measurement in the logical, quantum mechanical language. The thing is that the meanings which can be associated with words and symbols in common sense and in the quantum mechanical sense, they sometimes may be in this sense different. So sometimes we mod out something which we call something we in the commonsensical sense indeterminate as a sentence, or the way we just articulate uncertainty relations. So indeterminate is not nothing. So it's not necessarily in the commonsensical, if you cannot determine something or it's not indeterminable, so it's not a fundamental nothingness. No. So it's also a state in which there is an impending judgment sort of thing. Impending judgment about many possibilities. That's it. So, ordinarily, for example, logic, which is constructed as truth valued, where we have true, a statement is true or it's false. So we can also have something called, apart from these two statements, we can also have a indeterminate as a possibility which exists, not true statement, not a false statement. It's in between, in that sense. So even in Bohr-Heisenberg interpretation, intermediate may also not be taken. The thing is seriously, because somehow it also just tells upon something, the Aristotelian logic. If you say A is B, B is C, this means A is C. So, but if you have an indeterminate something, that law of excluded middle, it might not be, it somehow leads to an assertion which will somehow just question the pillars of traditional logic, Aristotelian logic. And we can express the fact that we can also say this indeterminate as something which is unobserved value, can be taken as indeterminate. So what will the unobserved value take? For example, if I say Mr. Suhail is casting a die, it will get it will get 6, and Mr. Yasir is having a die, it will cost 4. So what the question is, for example, this Yasir and Suhail have cast 2 dice. So if once you cast a die, it's not neither 4, neither it's 6, it's 2. So you have, in a practical sense, excluded one of the two. But you have not, you cannot a priori say what if Yasir has 4, had cast a die, it came out 2. But from this, you cannot have a judgment that what Suhail's, if we are going to test it, whether what Suhail has said, whether it will come right or not. So we can say there can be a value of judgments which can be derived from the unmeasured or impending observables which we have been which we have yet to decide. So our judgment may come out to be accurate, more accurate, if we can somehow, what I should say, see, for example, if Suhail, the weight of Suhail, his muscles, his whether he is hungry or not, how much energy he is. So those parameters, if we just take those into consideration, our accuracy may increase in that sense. So we can say the idea of unknown or unobserved, it itself fluctuates along a series of values, to say the thing. We can say intermediate in that sense. Even if we can also take into consideration how Laplace is a super deterministic thing, or in our today's understanding of meta observer or super observer, observing outside the universe. We can be God or an abstract something who knows things from start to end. Since we are not gods, our judgments impending judgments have an uncertainty attached to them. So we can see. So before how we can deal with this idea of indeterminate, it's better to say, for example, if there is observed language, and the way we drew a chart previously, quantum mechanical language. So in observed language, you can have measurement, this on u. If it's true, it's true. So the quantum mechanical language, if it's u, if it's u, if it's u, if it's true, it will also be true. So if it's true, false, so it will be false. False, true, it will be false. False, false, sorry. So here in the previous case, false, truth, because it was a false, or false, false was false. If you remember, it was there. Yes, yes. No, it was meaningless there. There it was meaningless. 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 So now we can say it's indeterminate. I. So these two operations in the quantum mechanical sense, once you invoke these things like that. So you can also say once your interpretations, whether it was exhaustive interpretation or it was restrictive interpretation, sometimes once you had a restrictive corpuscular interpretation, you explained something, but you narrowed down your statements in a certain way. You excluded other possibilities. But if you included all the possibilities, you missed some finer point. So that's it. So you can use rather than in this context of indeterminate, rather than having a corpuscular interpretation or a wave interpretation, you can also have an interpretation which was a corpuscular language or wave mechanical language. We can have a neutral language, which will basically just take care of those gray areas or shades which are not taken care, which cannot be exactly bracketed in terms of logic on-off systems like Boolean way. So in that sense, we can talk of something called multi-valued logic. People are so multi-valued. So people who want to logic. So if you want to go deeper into role of logic and symbolization of logic, language, and any physical world, quantum mechanical world. So classical world also has a classical logic, and there can be rules. But once we enter into quantum mechanics, so how we take account of indeterminate, which means there are many possibilities which have been suspended, which can take value, which depends. So maybe people like Tarski. Tarski has written a very interesting book, Logical Syntax of Language, something like that. Syntax of logic, if I remember. So I don't remember. Logical syntax of language. But here we are more interested in. So here, Reichenbach is of the opinion that the way we can have classical logic, we can have quantum logic. In classical logic, the way how we can classical physics, how we can we don't rehabilitate, how we can account for probabilities. We can account for probabilities in a classical sense, which can be two-valued logic. Yes, no. But the probability valued logic. So once we take indeterminate in this quantum mechanical thing, how we can account for the probabilistic logic? That's it. Since probabilistic logic is generalization of probabilistic logic is generalization of two-valued logic. Or according to Reichenbach, we can have truths of continuous or different gradations. Yes. Where a truth and false as a statement is required in that sense. But maybe it needs a different separate thing. How can account for probabilistic logic, which is not two-valued logic, which is indeterminate, or which may be many-valued logic. So it's a separate study which will just topologically different category. Maybe in the book of Isham's book, maybe there are some. If I remember well, there is a discussion of this thing. Now we can just have how we can somehow see these things, how we can somehow account for what I should say, this symbolic logical rules of so before we are going to just because we have to account for interpretation of three value logic. So before we are going to go for that, we are going to rehabilitate before making the case for three value logic, which will take account of indeterminate and quantum mechanical logic. We will try to make a base of it and see what are the rules of two valued logic. So two value logic, for example, you can have some statement. For example, A bar is a non-A or its negation. A, this B is basically A or B or both, or it can be conjunction also. A dot B is A and B, conjunction. A, this means A implies B. So this is equivalent to A equivalent to B. A equivalent to B. So now this sort of we assign things. So if A is true, then B is true. So we can have this thing. How we can have these implications which are associated with these statements. For example, if we have a board here, this is A, its negation. It's A negation. Negation is A bar. A bar is negation. If it's true statement, negation is false. If it's false, it's true. Negation of truth is false, negation of false is truth. And now you can also have a chart for this thing, entire thing. For example, if we have A, B, this is truth, false, false, truth, and false, false. The way we have done it. So now you can see, if we have, for example, a disjunction. Disjunction means A union B. This is a conjunction A dot B. Its implication, it's A equivalence is A is equivalent to B. So truth. Disjunction means, so if you have truth with truth disjunction, it will get truth out. Truth false, the disjunction will be truth. False truth, again false and truth. If you would have disjunction, you will get truth back. False, it will get false back. Yes. Truth conjunction, you will get truth back. Truth false conjunction, it will get false. False truth, in disjunction you can get truth back. In conjunction you will get false. For truth statement, when seen with false statement, it will give false statement. This will give false statement. Implication means truth means truth. Truth falsehood means falsehood. False truth means, so false goes truth, the truth statement remains same. False statement and false statement, it will still be a false statement, but that's a true statement. So if truth is equal to truth, it's a truth. Truth is equal to false means it's a false statement. False is equal to truth means a false statement. False is equal to false, this means it's a true statement. So it's in this simple sense how we can construct these tautologies. So what we have used, there's an important word, something called tautology. Students of linguistics and students of logic are aware of this statement. Tautology means agreed upon linguistic rules in that sense. But for a mathematician or for a logician, those symbols may be empty. But for an empiricist or a physicist who is more interested in the physical world, once we delve into those tautologies and once we impose those tautological symbols to some real quantities, whether they are real, true, false, they are implicate, they are indeterminate, the thing is that the symbols they don't become empty. So we're imposing tautologies on some real things in that sense. But the implications associated with tautologies, they can be somewhat very much helpful in that sense. So you can have different identities. For example, A is equivalent to A means rule of identity. A is rule of double negation, or the way you have studied A, this is De Morgan's rule. A union B is this. This is De Morgan rules. It has it's the way we have distributive law for listing rules of counter superpositions and other things. That's it. And now the other thing is a synthetic statement. Also, synthetic statements also all used. For example, a formula has sometimes true and sometimes F in its column is called synthetic. So synthetic in that sense, normally we say synthetic is has a subject and predicate. If they can have a strict mapping of subject and predicate, it's called analytical statement. If the subject carries more to it, apart from you can derive predicate from the subject from the predicate, we normally talk of synthetic statements. So here a synthetic statement is, it may sometimes T, sometimes F in its column. So it can have both possibilities, truth value as well as falsehood in that sense is contained in that sense. So I have a statement F is normally, which is only false statement, it will be a contradictory statement. So I'll just end this class with this statement that so write it here. So before so this we will be doing in the next class, interpretation through a true-valued logic. So before doing that thing, what we have learned is that we should be easily be able to construct rules which allow us to manipulate logical formula in a similar way like that of mathematics. Okay, we should be able to construct rules which allow us to manipulate logical formula. Not only for this classical logic, but we are interested now in the three-valued logic. How we can just incorporate indeterminate, which is sort of an impending judgment, which depends upon which has many layers to it. Now the thing is, how can logicize that quantum mechanical three-valued logic? In that sense, that will be part of our next class. So we'll stop here.